Hey guys, how you doing? I hope everybody's doing well, staying safe, everything like that. So back with 5-Minute Math. I think I'm changing the name already from 5-Minute Tutorials to 5-Minute Math. So the goal is to get this in 5 minutes or less and help you understand math a little bit better. So we talked previously about domain. Now we want to talk about range. All right, what is the range when you're given a set of data? Or also, what is the range when you're given a graph of something? So domain, if you remember, is the set of x values. Range then is going to be the set of y values. Okay, I think we said before it would be inputs, this would be outputs. Also, we talked about independent variables being the domain. This is going to be the dependent variables. All right, so now having said that, let's think about this. If the domain was the x values and data is presented to us in xy form, then we want to think of range as all of those, the y values. So given a set of data, I've got 3, -6, I've got 5, -10, and I've got 6, 4. Okay, the question is, what is the range? So that's the x value, that's not range, that's not range, that's not range. The range of this set of data would be the set of, I'm going to find the smallest one first, -10, then -6, then +4. So that's how we determine the range from a set of ordered pairs or set of points on coordinate plane. All right? Now, let's think about this from a graphical standpoint. How do we determine the range? So, very simple graph here. X-axis, y-axis. All right, so something that's quite easy. We'll go something linear. Now notice the arrows on the end. They basically let me know that this graph goes on and on and on and on and on. It goes forever. Okay, so is there a change in the range, or excuse me, is there a limit in the range on the vertical axis? In this case, there is not. So how would we write that? We'd write the range in two different ways here. I got the range of this graph is basically the set, which is -infinity to +infinity. That's going to be interval notation. Okay? The range could also be termed as all real numbers. That double-staffed R means all real numbers. Again, there's no ending vertically to this graph. Okay? Now, what if we have a graph that does have an ending, maybe a top, a bottom, things like that? So let me give you one example for that. We'll come over here to this space, right up here. Okay, so let's say I have a graph that is a closed-in point right here, and it's located at the point -2, +2, and I have a point down here that is located at +3, -2. Okay, and the graph would do something like this. Okay, now both ends are closed in. Okay, both ends are closed in. That's a closed in point there, it's a closed in point there. So my range is going to be the bottommost y value, which is -2. Okay, and it's going to go from -2 to the topmost. Actually, I did that wrong if it goes above that. Okay, so we'll turn this and go like this. Okay, the topmost value would be the +2. Okay, so we go to +2. Now notice how I did this. I got a bracket on the left, a bracket on the right, because those points are closed in. If they were open, it wouldn't be a bracket, it would be a parentheses. Okay, now I can also write this like this. The y values for this graph, in this case a function, are all the y's greater than or equal to -2, because here's the lowest y value. They are also less than or equal to +2. So this right there in that box means exactly the same thing. Hopefully that helps you. Again, it's been 5-Minute Math with Coach Harris. Have a good afternoon.